In this warm-up, we're using a set of congruent figures to write corresponding parts of the figure. The order in which the letters are written tells us which one corresponds with which point from the second figure. So I see here that A is the first letter, so E is going to match up with A. D comes next, and that is the last letter, so it's going to match up with H. And C is the third letter, so it's going to match up with G. Please use that same logic as you complete the remaining correspondences for points, segments, angles, and figures. One, do you think the tabletops are congruent? Use a transparency to check, and then explain your reasoning. So we can trace figure X, and there's already a vector drawn in here, so let's start by translating along that vector. Then if we hold our pencil on B and rotate clockwise, will X map to Y? And you can see that they do, in fact, line up. Since they line up, we can say that they are congruent. For problems 2 and 3, use a transparency to determine whether the given figures are congruent. If so, describe a sequence of rigid motions that maps one figure onto the other. If not, explain how you know. We're going to start by tracing one of these figures. I'm going to start by lining up one figure's points with the other. So I see O and I should line up, so I'm going to translate along OI, the vector. Now O and I are lining up, so I'm going to rotate until this straight line matches up with this straight line. And I'm going to hold my pencil on I. And I would describe that as OG coinciding with IF. And it should look something like this. Now I'm going to reflect over IF so they map to one another. And they do match up, so they are congruent. And this would be the sequence of rigid motions that maps it from one to the other. Number 3. C is supposed to line up with H, so I'm going to start by translating C to H. O, this point here, is supposed to match up with E, this point here. But no matter how much I turn it, it's never going to be long enough to reach from H to E. I could try reflecting it, but then it would look like this, and it still isn't going to line up perfectly. So these figures are not congruent. There is no combination of translations, rotations, and reflections that would make these line up perfectly. They are not the same size or shape. Here are some examples of congruent figures in real life. This is a textile, and you can see that there are congruent lines, or you can see that there are congruent of these smaller lines in this pattern. American Indians, known as Navajo, began weaving textiles such as this one in the 1700s, and they continue to produce various weavings to this day. Very few weavings have been preserved, but the one we are looking at now is a chief blanket that was made around 1840. A Navajo chief would wear the blanket almost like a jacket. These blankets were quite expensive to make, so the chief would be the only person who could afford one. The Navajo, like the people of many other cultures, also created hand-woven rugs with repeated patterns similar to the one in problem 4. So you can see this this patterned rug textile, and it says, circle 2 congruent figures in the rug. Write a sequence of rigid motions to show that the 2 figures are congruent. Draw any needed vectors, lines of reflection, or points of rotation. So these sections are the same. You could draw in a vector that would connect for a translation. You could also show that these two are the same, and this would be a reflection across a vertical line through the center. There are several other congruent figures in this textile that you could circle and describe the sequence of rigid motions that would map them to each other. Apply any rigid motions to the given pattern in quadrant 1 to create a congruent pattern in quadrant 3 and 4. Describe the sequence of rigid motions that maps the pattern in one quadrant onto the pattern in another quadrant of your choice. So it looks to me like a rotation occurred here. You do not have to continue those patterns. You could do a reflection or a translation. It's up to you, but I would like to continue the pattern here. So I'm going to rotate 90 degrees to fill in quadrant 4. So I'm going to write that down here. I rotated quadrant 1 90 degrees to create quadrant 4.